This video is going to be about how to graph rational functions. Make sure you have already watched the video about finding vertical asymptotes and finding horizontal asymptotes first before you go on to this one. The reason I say that is because if we want to start graphing rational functions, where I would usually start at is by finding any asymptotes that we may or may not have. So any vertical asymptotes, any horizontal asymptotes. To find vertical asymptotes, remember what we do is take the denominator, set it equal to 0, and solve out. So in this case, our denominator is x minus 1, so we'd set that equal to 0. Nothing too fancy here, we'd just add 1 over, and we get a vertical asymptote of x equals 1. For a horizontal asymptote, the way we do that is we want to check the degree of our numerator and compare that to the degree of our denominator. Well, our numerator would be a degree of 0, whereas our denominator has a degree of 1. Because our numerator degree is less than our denominator degree, that tells us that our horizontal asymptote is going to be y equals 0. So, to start graphing then, we want to mark out these two asymptotes to know where we can graph and where we can't graph. So if we draw out our x and y axis here, if we want to make our vertical asymptote of x equals 1, well, that means we want to count 1 over to the right, and then we're just going to make a dashed line there to represent that invisible line that the graph can't cross in a vertical asymptote. Do keep in mind, this is only us, since we are graphing this by hand, we're going to make dashed lines here to show this asymptote. If you graph this on some sort of graphing calculator, it's not going to show you the asymptotes. You're just going to see how the graph itself actually bends away. But since we can't be as perfect as a graphing calculator, we're going to make some dashed lines here so that we can see where we don't want to let our lines cross. So our horizontal asymptote is y equals 0. That one's a little bit harder to show because it is the x-axis. So you could make some extra dashed lines off here to the left, or we can try and maybe thicken up along the axis a little bit here. But something to kind of try and show that we aren't going to be allowed to cross the x-axis either. So the idea here is when you have just a basic graph, your x and y axis kind of split the graph up into 4 quadrants, right? Well, now, with the two asymptotes that we have drawn out here, the vertical and the horizontal asymptote, we have kind of split the graph up into our own 4 quadrants. And what we don't know yet is where in this we're going to be graphing. Now, we do know that if we were to graph in this area here, then we won't be able to graph in this area, because it is a function, right? And a function has to pass the vertical line test. And so if I have any type of graph, if I have like a dot here or here, well then I can't have anything down here, right? And same thing goes for the right side of the graph as well. If I have any graph here, well then I know I won't have any down here. But while we can make some logical conclusions off of just that type of information, in the end, the only way we're going to know for sure is if we just make ourselves an XY table and plug in some points to figure it out. I would like to figure out what the left side of the graph is going to look like first. So knowing that my vertical asymptote is x equals 1, I'm going to pick a few points that are to the left of 1. So meaning less than. So like 0 or -1 would be points that we could plug in here. If we plug in 0 to our function, remember we'd be plugging in for x right there, right? So if we plug in 0, that means we would have 1 over 0 minus 1. Well, 0 minus 1 is -1, and 1 divided by -1 would give us -1. So apparently 0, -1 is a point right here. If we were to plug in -1, well, if we plug in -1, then we'd have 1 over -1 minus 1. -1 minus 1 is -2, so we'd be getting a -1/2, meaning a dot roughly about there. And you could keep plugging in points, and the beauty of XY tables is you can pick any points you want, so you don't even have to use -1 and 0 the way I did. But what you're eventually going to see here is this shape will begin to show up where curves down because it can't get to the vertical asymptote of x equals 1, and it curves off to the left because it can't touch the x-axis because of our horizontal asymptote. And if you graph this on a graphing calculator, it would continue getting closer and closer to each of those asymptotes until honestly it would end up almost looking like it touched. But if you zoomed in, you'll see that it will never actually touch these asymptotes. That tells us one part of our graph, but we know that we have more than just that for this graph. We want to figure out what happens to the right of the vertical asymptote, to the right of x equals 1. So pick some x values that are to the right of 1. For example, a +2, right? We could plug in a +2, or we could plug in a +3. If we plugged in 2, that means we would have 1 over 2 minus 1. Well, 2 minus 1 is +1, so 1 divided by 1 would give us 1, meaning we have a point right here. Do make sure you are careful and that you are always counting from your origin. Do not let the fact that you have kind of, created your own axes with these asymptotes distract you from where 0, 0 is. Make sure you're always counting from 0, 0 when you go to graph. If we plug in 3, we'd have 1 over 3 minus 1. 3 minus 1 is 2, so we have 1/2. You can see kind of the pattern, the symmetry that we have here whenever I'm plugging in because of the points that I've picked. But again, you can pick whatever points you want, so it doesn't really matter. But what we end up seeing after you plug in enough points is we see it mostly curves off to the right as it tries to head downwards. Or I really should say it curves slightly down as it heads off to the right. And then as it's going to the left, it ends up curving very sharply up because of the vertical asymptote. That is what you end up having for your graph, and most rational functions are going to end up looking somewhat like this. Do you recognize if you have more than one vertical asymptote, then you're going to have a very different looking graph because you'll have more than just two sections. But if you have just a single vertical asymptote, most of them will either end up looking like this, or if you end up with a negative fraction, then you may end up with some with the spots for the graph being flipped, meaning instead of the bottom left and the top right, having the top left and the bottom right. But that's for you to play around with some with whatever other functions you want to practice with.